Alright guys, let's give this a whirl. This is my first video I've ever made, so bear with me. You can keep the same objective from yesterday. We're going to just continue with that, except today we're focusing on the perpendicular lines. So, same as the last couple days, we're going to write equations of lines, and what is it that you need to write any equation of a line? You have to have a slope, you have to have a point. So the only difference today, we're going to do the exact same thing, but we're going to pick a different way of finding our slope, and then we'll still be given our point. So we got to figure out something about the slope of perpendicular lines. That's what we're trying to accomplish today. So we did this yesterday. We'll just skip through that for just a minute. Okay, here we go. Perpendicular lines, I think you already know this. They intersect at 90-degree angles. So you've got this right corner down there, and you know that already. So that's a perpendicular line. What we're really concerned about is their slope. So if you look at this red line right here, and you look at the slope's always stuck to the x, and you look at this blue line here, and you look at that slope, there is something that we want to notice. And what we notice there is going to be the exact same for every set of perpendicular lines, except for this special case over here that we'll look at. But what we should notice is that one of them is always going to go uphill and one of them is always going to go downhill so that they can cross. So they will always be opposite, and then they will always be flipped upside down. So this is 2 over 3, this one is 3 over 2. So perpendicular lines, slope will be, this should go in your notes, opposite and reciprocal. Dog just banged down the door. So, here you have a negative, this one is positive, this one's 2 over 3, this one's 3 over 2. So, if I give you a slope of m equals 5, find me the perpendicular slope. So, take a second and try that. Opposite of a positive would be a negative. What's really underneath that 5? If there's nothing there, there's a 1, so I can flip that upside down, so it would be 1/5. If I gave you a slope of negative 1/2, take a second and find you can pause this and find the opposite and reciprocal. So the opposite of that would be a positive, flip it upside down, and you'd have 2 over 1. One more. If I have I don't know, 1/4. Opposite of that would be a negative. Flip it upside down and we have 4 over 1, or just a plain 4. So this is going to be very, very important. We've got this special case down here. This is when you have just a straight line going straight across to y equals. You guys know how to make that. Or if you have a plain old x equals. If you have one going straight across, one going straight up and down, these will always be perpendicular, as you can see. So let's move on. We did something like this yesterday, so this should look very familiar. First thing we're going to do is we're going to get them in slope-intercept form, and then we're going to check the slope of them and decide which is opposite and reciprocal. So this one here is easy. We've already got the slope sitting there. We can clean this one up a little bit. We can distribute here, and we'd have y equals negative 1/3 x. Straight across the top, straight across the bottom here, we'd have plus 4/3. So here's my slope. And these two are going to be perpendicular because this one's positive, this one's negative. This one's 3 over 1, this one's 1 over 3. So we can see that, and those two have to be perpendicular. And then we have those two sneaking in here. This is a line that's going straight across. This is a line going straight up and down. So these right here are the ones you're going to have to really pay attention to for the quiz or the test. They're going to sneak up on you. And if you're not sure, just graph those quick. If y is 3, y is going to be 3 no matter what x is, forever and ever and ever. It's going to go up here and go straight across. If x is negative 2, it will be negative 2 no matter what y is, so it will always be right here. Let's move on. We'll try one more. We've got this y equals 1 right here. We can graph that really quick. Y is going to be -4 no matter what, so it's going to be right there. X equals 3. X is going to be 3 no matter what, so that's going to be right here, and we're going to have our perpendicular lines. These two we have to clean up, so let's clean those up. So we have 5x plus 20. And we can add this 6 to both sides. And we have y equals 5x plus 26. And this one's already nice and set up for us. So again, one's negative, one's positive, one's 1/5, the other's 5/1. Those are perpendicular. This here, there will be something like this on your test. This says to show that we have a right triangle. And hopefully you guys all know that to be a right triangle, you have to have a right angle. And so we hope, we're guessing that maybe it's right there. But if we're going to have a right angle, what kind of lines meet at a right angle? Hopefully you said perpendicular. Perpendicular lines always make a right angle. So if we check the slope of each of these lines right here, a couple of them better have perpendicular slope, I'll say are not a right angle. So let's check the slope of this one. That one looks like it is up 2 and over 3, so up 2 and over 3. If I check this one right here, that one looks like it is down 1, 2, 3, 4, 5. And backwards 1, so down 5 and backwards 1 would just be a plain old 5. And this one is down 1, 2, 3 over 2, so down 3 over 2. So this one's negative, this one's positive, this one's 3 over 2, this one's 2 over 3. These lines have to be perpendicular because their slope is opposite and reciprocal. And if they are perpendicular, then they make a right angle. And if there is a right angle, then this is a right triangle. So you'll have to do something like that on your quiz or your test, and we can talk about that more tomorrow. Quickly again, we can prove this. This is up 2 over 1. If I check this line right here, that's going up 2 over 1, so we got a slope of 2. This one is going down 1 over 2, down 1 over 2, down 1 over 2. So that line right there, down 1 over 2. So again, we got a positive and a negative. We got a 2 over 1 and a 1 over 2. So those are perpendicular, which means they make a right angle, which means this is a right triangle. Okay, this should look like yesterday. Write an equation in slope-intercept form for a line that passes through this point and is perpendicular to this. So, what are the only two things you need to write the equation of any line? You have to have a point, you have to have a slope. And what do we already have? We have a point, so we've got that covered. So we're looking for a slope. So if it is going to be perpendicular to this, what is the slope of this line? The slope of this line is 2. So if it's going to be perpendicular to a 2, what does the slope of our perpendicular line have to be? It will have to be opposite of that, and we'll have to flip it upside down. So if it is going to be perpendicular to this, it's going to have to be opposite and reciprocal. So our slope of our perpendicular line is going to be -1/2. So now I have a point and I have a slope. Once I have those two things, I don't care about this anymore. I have nothing to do with it. The only reason I needed it was to figure out what my perpendicular slope was going to be. So once I have a point and a slope, I'm good to go. I will do this one using method 1. I'll do the next one using method 2. And then you can give it a try. So method 1, y minus y, so y minus -1 equals m, -1/2, times x minus x, which is right there. So this becomes a giant plus sign, my minus and minus here. I have y plus 1. I distribute that, I get a -1/2x. I distribute this. Straight across the top is 2, straight across the bottom is 2. So 2 over 2 is 1. Negative times a negative is a positive 1. Minus 1, minus 1. These cancel, and I get y equals negative 1/2 x plus 0. Or you can just leave it as y equals negative 1/2 x. And this is method 1. I'll do the next one in method 2. So, the only two things we need to write the equation of a line are a point and a slope. We have a point. We need to find a slope some way, somehow. And they tell us right here they want it to be perpendicular. So if it is going to be perpendicular to this, what is the slope of this? The slope of this is 5. So something perpendicular to a 5 has to be opposite, flipped upside down and reciprocal. The slope of something perpendicular is going to be this. Now that I have my point, I have my slope, I don't care about any of this other stuff anymore. So now I'm going to do this one using method 2. So method 2, y equals mx plus b. Y equals something times x plus something. So I plug in my y is 3. My slope is negative 1/5. My x is negative 5 plus b. So negative 5 over negative 5 is a positive 1. So 3 equals 1 plus b minus 1 minus 1. B equals 2. So I've got my 2 and my slope right here of negative 1/5. I think that might be the last slide. This is the last slide. I'll let you try this one on your own. There's one catch here. So what is the only catch here? I've got my point. I need to find my slope. How do you find the slope of something like this? You have to make sure you get y alone. So make sure you get rid of this 6 before you try to find the slope. Now these cancel. I have y equals 1/2 x plus 2. So be careful in your homework. Make sure you get y alone first. So the slope of this is 1/2. And I need it perpendicular to that. So if it's going to be perpendicular to that, it's going to be negative 2 over 1, which is just negative 2. So now you have your point, you have your slope. Why don't you pause this and try it by whichever method you like. And I'll put the answer on here in just 1 second. The answer will be... So y equals negative 2x plus 10 is going to be your answer. And you can start your homework, and I'll answer any extra questions you have tomorrow.